On July 1, 2025, NASA officially announced the discovery of the third interstellar object ever detected, named 3I/Atlas. This mysterious visitor was streaking through our solar system at an astonishing speed, shining brighter and behaving more oddly than any previous interloper. As scientists delved into its erratic orbit and unusual chemical makeup, they decided to feed all the available real-world data into the planet's most sophisticated quantum AI system. When the computations wrapped up, the findings were so alarming that many experts are still grappling with their profound implications. If these models are even remotely accurate, we could be dealing with a crafted entity on a calculated trajectory, one that reveals weaknesses in our cosmic defenses we never anticipated. How could a wanderer from beyond our stars rattle the foundations of our cutting-edge technology? Let's dive deep into the events surrounding that quantum simulation and uncover why its conclusions are downright chilling. It all began on that fateful July day in 2025. The Atlas telescope, nestled in Chile's Rio Hurtado Valley, picked up a faint, moving speck in the sky, registering at magnitude 18, hovering just above the galactic plane in the constellation Serpens Cauda. At first glance, it resembled a typical minor planet, but its movement didn't align with expectations. Astronomer Larry Deno, sifting through the readings, spotted the anomaly. The object's path sliced across the star field at a sharp incline. Within hours, the Minor Planet Center issued a provisional label, a 11PL3Z. In the following day, telescopes from observatories spanning 3 continents chimed in with additional observations. Every fresh data point reinforced the same startling truth. This wasn't your average comet. Its trajectory was hyperbolic, unbound by the sun's gravitational pull, far exceeding typical bounds. The eccentricity clocked in at over 6.2, eclipsing the previous record held by 2I/Borisov. Hurtling along at 58 kilometers per second, it was more than double the velocity of standard asteroids. By dawn the next day, the designation was updated. 3I/Atlas, marking only the third confirmed interstellar intruder. Word spread like wildfire among astronomers. Unlike comets originating from the Oort cloud, this one hailed from the depths of interstellar space, its origins etched in its extreme speed and entry angle. Preliminary size estimates ranged from 10 to 30 kilometers in diameter, rendering it the bulkiest interstellar guest on record. Even at 4.5 astronomical units from the Sun, its luminosity surpassed predictions. The Atlas network, engineered for planetary protection, had snagged a true extraterrestrial enigma. Yet the true revelations lurked in the finer details. The orbit wasn't merely open, it was virtually linear, scarcely influenced by solar gravity. Tracing backward, its route pointed toward the Milky Way's dense disk, suggesting an antiquity predating our own solar system. Archival footage from the Zwicky Transient Facility and Pan-STARRS dated its approach back to June 14, 2025, refining the orbital calculations with each image. Astronomers buzzed in late-night discussions. The velocity and hyperbolic form erased any doubts. 3I/Atlas was an authentic cosmic nomad, a rarity in astronomical annals. Prior detections included Oumuamua in 2017 and 2I/Borisov in 2019, making 3 in under a decade feel improbably frequent. With confirmation secured, a worldwide frenzy ensued. Major observatories trained their lenses on the newcomer, eager to snag spectral data, brightness variations, and compositional clues. The core metrics, speed, radiance, and pathway, sparked a mix of excitement and apprehension. 3 interstellar arrivals in 8 years, after eons of quiet? The mere spotting was a statistical aberration. But the deeper irregularities, the ones testing scientific boundaries, were yet to emerge from the datasets. As 3I/Atlas's path solidified, astronomers globally cross-referenced their findings. Nothing matched established norms. Oort cloud comets typically meander in with wide, curving loops, heavily warped by solar forces. Not this one. Its eccentricity exceeding 6 painted a near straight line, barely a bend. For perspective, Oumuamua's eccentricity hovered just over 1. Here, it was sextupled. Successive observations only sharpened this reality. The velocity at 58 kilometers per second could bridge Earth to the Moon in under 2 hours, dwarfing prior interstellar benchmarks. At such a clip, 3I/Atlas would linger inside Jupiter's orbit for mere months before vanishing into the void. But its glow puzzled most. At 4.5 astronomical units from the Sun, it reflected excessive light, initially hinting at a 5.6-kilometer diameter, later refined. It outshone comparable comets, with a nascent coma, a hazy envelope, forming prematurely. The inbound path, aimed at the Milky Way's thick disk teeming with primordial stars, was another quirk. Its inclination, mere degrees from the ecliptic, defied the randomness expected of interstellar objects. Calculations pegged the alignment's probability at under 1 in 500. Then, the planetary proximities, brushes with Mars, Venus, and Jupiter, each within tens of millions of kilometers. It resembled a methodical scan, too neat for serendipity. Discussions in forums and emails swirled. Was this celestial fluke or design? The Minor Planet Center's daily orbital updates affirmed the enigma: hyperbolic form, excessive brightness, near-planar entry. No standard comet paradigm fit this large, luminous, swift entity. Conventional physics faltered, prompting talks of advanced simulations. With myriad variables, quantum AI emerged as the sole path to model all scenarios simultaneously. Traditional methods had peaked. Grasping this interloper's essence demanded unprecedented stakes. For ages, classical computing underpinned astronomy, dissecting orbits into sequential microsteps. But 3I/Atlas overwhelmed this paradigm. Its data, velocity, trajectory, luminosity, fractured models. Simulations viable for Oort comets or Borisov disintegrated, yielding divergent fogs instead of clarity. Adding variables exacerbated the chaos. NASA's Quantum Artificial Intelligence Laboratory, QAIL, confronted these barriers. The issue transcended speed, it rooted in computational essence. Classical systems tackle scenarios linearly, but 3I/Atlas branched endlessly. Solar winds, non-grav forces, outgassing, even speculative maneuvers. This led to exponential complexity, outpacing supercomputers. Quantum mechanics provided escape. Rather than isolated paths, quantum setups probe multitudes concurrently, like a coin in heads and tails limbo. Simulations encompass all trajectories, chemistries, and gravitational dances in parallel. This isn't mere acceleration. It's a paradigm shift. Superposition sustains all states until observation collapses them. For 3I/Atlas's unpredictability, it unlocked elusive insights. Transitioning to quantum wasn't optional. Classical coherence evaporated. Quantum AI charted possibility terrains, illuminating outliers, exotic reactions, and subtle artificiality hints. To decode this oddity, simulations embraced every improbable avenue. Quantum AI promised not raw power, but profound revelations into the enigmatic. Crafting a simulation for 3I/Atlas transcended routine setups. At QAIL, a hybrid quantum pipeline materialized, blending cutting-edge tech, core, a CUDA cluster of 124H100 GPUs tailored for quantum throughput, hardware for elite labs or massive AIs. Now it unraveled an entity flouting physics. Data volume was immense, velocity, tilt, forces, outgassing encoded as qubits. Terabytes from observations fueled runs branching into millions of timelines. QDAC orchestrated quantum gates and entanglements for GPU execution. Workflow, classical prep cleaned data, then quantum handover. Noisy 40-qubit sims, weeks on supercomputers wrapped in minutes, echoing Google's benchmarks. Applied to space, it modeled three I/Atlas's full behavioral spectrum. Engineers observed as it mapped trajectories, signatures, interactions in superposition, collapsing on measurement, like a multifaceted coin flip. The cluster revolutionized analysis, enabling real-time tweaks, updated curves or elements, recalibrated possibility landscapes instantly. It evolved from program to multiversal viewport on three I/Atlas's fates. Setup complete, the run loomed. Revelations awaited. At NASA's Goddard, spectral teams pored over initial light curves. Chemistry veered off-kilter. On August 12th, James Webb targeted the Comet, revealing CO₂ dwarfing H2O 8:1, 129 kilograms per second, CO₂ versus 16 kilograms per second H2O, unprecedented for comets, where water dominates. Venting pulsed controllably like regulated spouts. Models mismatched standard sublimation. Pulses cycled steady silent surge. Traces like carbonyl sulfide and CO appeared in atypical ratios. Dust under a micron, finer than norm. One expert likened it to a valve, not icy melt. Venting synced with solar exposure, timing too exact, suggesting internal regulation. Pulses aligned with 16.8-hour rotation, implying sun-facing vents. Natural? Possible, but consistency sparked artificial modulation murmurs. If managed, it could propel or correct course. Quantum AI deemed emissions non-random, akin to engineered vents over database comets. Whispers grew, controlled mass loss for steering, unsettling, implying oversight. 8:1 ratio, timed pulses, mismatched chemistry, if steering, who commands? 3. I/Atlas's tail defied comet norms. High-res images showed not diffuse fan, but tight column, like jet exhaust. Pulses matched rotation, flaring at specific longitude. Spectra, CO₂-rich plus nickel sans iron, rare, as their stellar pairs. Nickel evokes alloys for thrusters, heat shields. AI flagged dynamics as non-comet-like, coordinated for steering. Simulations. Timed pulses enable nudges, like swimmer kicks. Plasma exhaust analogies emerged. If tool, not byproduct, implies purpose. Nickel hints at unseen processes. Unsettling. If propelled, what intent? JPL trajectory experts inputted data, yielding disbelief. Post-inner system. 28.96 million kilometers from Mars, October 3, 2025, 97.15 million kilometers from Venus, weeks later, 53.7 million kilometers from Jupiter, March 16, 2026, tight uncertainties. For Interstellar, uncanny, random paths, miss planets vastly. Odds, less than 1 in 20,000 per Monte Carlo on JPL horizons. Like planetary survey, Mars pass post-opposition, Venus near inferior conjunction, Jupiter post-solar, coordinated, not chance, backwards integrations, clean hyperbolic from Sagittarius at 58 kilometers per second, suggests design, defying natural odds. If deliberate, it's waypoint traversal, probabilities scream warning. Interstellar models assume randomness, space vast, orbit slim. But 3 I/Atlas aligned ecliptically, less than 1 over 500 odds. AI Sims reiterated sequence. Mars, Venus, Jupiter, timings aligned. Odds, less than 1 million. Compared to priors, unparalleled. Intent discussions arose, not conclusion, but query. At randomness's edge, alternatives loom. AI's numbers, cautionary tale. 1 in million doesn't prove, but planetary checkpoints evoke sci-fi turn plausible. AI output, probability cloud. Core, less than 5% natural random rock. Rest, derelict or active modulation, controlled emissions, corrections. Flagged flybys as improbable sans direction. Verdict, if guided, risk escalates. Derelict relic versus actor, thin natural branch. Numbers hung heavy, less than 5% natural, rest disturbing. Atlas warns of threats, but limits persist. Chelyabinsk, 2013, 20 million rock, 440,000 kilograms of TNT, 1,600 plus injured, undetected. Blind spots. 3I/Atlas 10 kilometers plus, spotted by chance. Systems miss galactic glare, sun approaches. Gaps allow stealth. Chelyabinsk local, larger, devastates. AI flags, aimed, defenses inadequate. Close hit delta. Minutes. If adjustable, shields, fragile. Horror. Next, unseen strike. Cosmic shifts redefine us. Copernicus dethroned Earth. Galileo unveiled Jovian moons. Apollo showed fragile home. 3I/Atlas echoes. Sims hint non-random choreography. If odds true, Copernican jolt, minimal control over intruders. Sky permeable. Stars once orderly, now unsettling. AI revelations probe, surveyed, watched, message in orbits. No comfort, universe stranger, indifferent. Next visitor, different, closer. Data breeds unease, not alone. July 1st, 2025, 3I/Atlas, third Interstellar, brightest. Quantum Sims, 124 H100 GPUs, less than 5% natural. 8 to 1 CO, 2 to H2O, nickel tail, sans iron, improbable path, 28 million kilometers Mars, 53 million kilometers Jupiter. Defies randomness. Data under review. Defenses, post-Chelyabinsk, unprepared. Each visitor. Warning, readiness test.